All right, guys. Good evening once again. Good to see you back. I hope you guys, well, some of you may indulge in Valentine's Day activities. Some of you may not celebrate it, but I hope you would have, for those who have indulged in the activities, you would have enjoyed your day yesterday. All right, so today we are continuing on probability. And of course, you know, we had started this class from last week on probability. So what I'm going to do briefly is to just review some of the things that we have gone through, and then from there we'll continue. All right, so the whole topic of probability is really an extension in statistics. At a high level, probability is inclusive in statistics. So when we're referring to probability, you can consider it as a part of the statistics that we are doing. All right. The definition that was given for statistics from previous class, we said the probability is a chance, is a science of chance. And as the word suggests, chance, when you think about chance, what really comes to your mind? Anybody can just give me a quick feedback on what you think when you hear the word chance, something happening by chance, what comes to your mind?
Possibility.
So is that there is a possibility? Anybody else with any other idea behind that word? All right, so in
something likely to occur again, sir.
All right, so in probability, we refer to chance of something happening as the likelihood of it happening based on what it is that you're favorable, that you favor in terms of what you want, what you're favor in terms of an outcome out of what is possible in terms of the total outcome. And a simple explanation can be in the tossing of a coin. If you toss a coin, you may expect when the coin falls, you may expect that the head of the coin may be up or the tails of the coin may be up. But chances are is only one you can have up, not both at once. So we say that the likelihood to get a tail or the likelihood to get a head is based on whether or not you favor a head or you're in favor of a tail. So whatever you're in favor of is what we are finding the probability of. So in other words, is what we are finding the likelihood of happening. All right, so we have the term event, and we must understand what an event is in terms of probability. So the process of getting an outcome is known as an event. So what you get after an event happen will be the outcome. And the process of the event is, for example, like drawing a card or tossing a coin. All of these are events that give possible outcomes. Rolling a die. Now, we generally call it dice, but die is singular and dice is plural. All right, so that's what we mean by an event. So in an event, we have some outcome after the event. So the process of getting an outcome is known as an event. You can also think of an event in terms of an experiment, the result of an experiment. The event would be the experiment and the outcome would be the results. All right. All right, so with that said, the probability is the science of chance. And why are we studying the science of chance? Because we know that in our day-to-day life, there are some things that seem to happen based on chance. But there are things in relation to, in terms of what is favorable and what is unfavorable, that can influence the chance. So if we have more possibility of something happening, give me a second, guys. All right, guys, sorry about that. So, so the chance of something happening would be based on what is the possible outcome of what you're in favor of, right? So if you think in terms of, some of you may like to play bingo. And if you think in terms of bingo, yes, good evening. You may have a bag with some numbers going from one. I don't know how many numbers in a bingo bag. Anybody knows? Anybody have any clue how many numbers are in the bag? But anyways, the idea is that you will have a total number of bingos, what you call them, bingo seed in the bag. And based on the number that you want, then the probability of that number occurring is how many of that number in the bag. So if it is only one number in the bag, then you would only have one out of the total amount of seeds that you have in the bag. So when we actually calculate probability, we are calculating as a fraction of a whole. So the whole would be the total possible outcome, and the fraction of that total possible outcome would be what you're in favor of. All right. And so that's what the idea behind probability is. All right, so we have some more definitions here. So outcomes with the same chance of happening are called equiprobable events. All right. So in the case of throwing a die, we notice that if we throw, sorry, not a die, but in terms of tossing a coin, we notice that the probability in getting a head or a tail would have equal chance, because they don't know which way the coin going to flip. But you know that the same chance of getting a head is the same chance of getting a tail. And so the chance of getting a head is two possible ways that the coin can turn up, either heads or tail. So the total possible outcome would be 2. But in terms of what you're in favor of, you're in favor of a head, that would be only 1 out of 2. So the chance of getting a head is 1 out of 2 possible outcomes. The chance of getting a tail would also be 1 out of 2 possible outcomes. And so in that sense, we would refer to the probability of getting a head or a tail as being a half, which is 1 out of 2. So the fraction that you get when you measure the probability is what give you the probability measure. And that can be simplified into what you would consider to simpler fraction. So if you can cancel out the fraction, you cancel it down to its simplest form, right? And that's that you should do when you're doing probability. So next definition, outcome. Outcome for the probability is being worked out. So the outcome for which the probability is being worked out is known as favorable outcome. So what you're in favor of. So in terms of the formula for probability, so if you're calculating the probability, and if you notice that PR really stands for probability, and whatever in the brackets is what you're in favor of. So we say the probability of whatever you're in favor of in the bracket will be equal to the number of what you're in favor of in the bracket over the total number of possible outcomes. So that's how you would calculate the probability of something that you're in favor of. Any question? Is that clear to everybody? All right, moving on. So we have some examples here that would give you an idea how to calculate the probability. So to find the probability of obtaining a head in a single toss of a fair coin, we notice that there are 2 equiprobable outcomes. So we can either get a head or a tail. So one of which is favorable. So if we choose head, that means you are in favor of a head. So we say the probability of getting a head is 1 chance out of 2 possible outcomes. Now, when we look at example 2, we see that to find the probability of drawing an ace from a deck of 52 playing cards, then what we have to do now is think about how many aces we have in the deck of cards and how many cards we have in total. So once you know the total number of cards you have and how many of those cards you are in favor of. So in this case, we are in favor of ace, and in the deck of cards, we will have 4 ace in the deck of cards. But the total number of cards in a pack of number of cards would be 52 in a deck of cards. And so the probability for an ace, we can only have 4 possible ace out of the total of 52 cards. So we would write the probability as 4 over 52. And then now we cancel down where possible to the simplest form of the fraction. So here we would have 1 over 13. Any question about that, guys? Everybody's following so far? All right, now I want to note the word fair. You might see in probability that they often use the word fair. So in this case, they say a fair coin. Now, when we talk about fair, is either something is fair or it is unfair. Now, when something is unfair, we know that somebody is cheating. So what would make a coin unfair? Or how can somebody tamper with a coin to make it unfair? Anybody? Mr. Adams?
Yes, sir. If the coin has the 2 same sides, like 2 heads on a coin or 2 tails on a coin.
Okay, well, that it would be a biased coin, and I guess it wouldn't be unnoticeable by the observer. So even though you can make a coin unfair in that way, I don't think you can actually trick anybody with that. But I get what you're saying. But which other way you think you could make the coin unfair so as to deceive whosoever you're playing with.
You can magnetize the coin, have one side be magnetized and have the surface that you made it fall on magnetized. So you ensure that that side is always down.
Right. So in that case, you would tamper with the coin so that the coin become unfair or biased. And so every time you toss that coin, it's going to tend to turn up on that side that you're in favor of. And that's one of the things that will happen in casinos where they tamper with machines that could have fair outcome. And they can do that in order to cheat you out of your money. All right, because as you know, gambling relies heavily on probability, relies heavily on chance of something happening. If you're playing a slot machine or a jackpot or something, it is based on the chance of having some numbers line up or something of the sort. So in that case, probability has a lot to do with gambling. All right, if we think about the lotto, you have different types of what you call betting games. And all of these betting games is based on the possibility of some outcome. And if you're even doing cash, what you call it cash pot, it will be based on probability. Now, one of the things that you will recognize is that if your favorable outcome is very low, it means that chances of it occurring would be low based on how many number of that outcome you would have. All right. So in terms of, say, winning a lotto, what you have a certain amount of numbers that can play in the lotto. And I guess it probably go up to 30 something. And out of 36 numbers, you have to choose, I think, about 6 numbers. And so when the machine plays, your chances of winning is based on those 6 numbers appearing. All right. Now, if you think in terms of how many persons buying the lotto, then that also, what I must say, lessen your likelihood of winning. The more persons buy the lotto, it's the harder it is for a particular individual to win. But at the same time, it is more likely that somebody will win when more people buy it. But it's not everybody going to get that opportunity. It's just one out of the entire population have a chance of winning. All right, so those are some things to consider when we're dealing with probability. All right, go ahead, Mr. Adams.
Sir, so what are the chances of that? So many people buy it and it's only 1 or 2 people win the jackpot. Isn't, if you say that you get tampered with?
Well, put it this way. It is not necessarily that it is tampered with, but when more people buy it, it decreases your likely chance of your number playing. But what it does for the lotto vendor is that when nobody gets the winning number, it means that they would make more money off the customer that way. And so when these gambling houses, they are using machines, they want to use machine where your chance of winning is very low. So you have a low probability of winning. And so once there's a low probability of winning for you, it means it is a greater yield for them because it means that they will be getting your money without you winning. All right.
All right. That's there.
So the tampering aspect, Mr. Adams, is when the event is affected by the tampering. So the event of of the outcome is the process of, in the case of the latter, it would be the process of these balls that are, if you ever watch the lottery, you'll see that some balls get float up in here, and these numbers eventually fall into a slot, and then these numbers become the winning numbers, right? So we're saying that the way that the tampering would happen is if they do something to that machine that is playing the balls. So in the tampering happen within the event of the outcome. All right.
Yeah, I get that. But
Right.
I feel that they have a machine that calculates a possible sequence that people buy, and then they set the machine accordingly. So it plays against whoever's buying. Because they can tell me that so many millions of people buy it and
it is
none
possible.
win.
It is possible, but I guess they set up the game for you to view it on TV to say that it is transparent. So, you know, it all depends on you, the player, or not you believe it is fair or not. But everybody, and the possibility that people are, because people are winning, then people buy into it because they are thinking that they may eventually have a chance of winning. But it's not very easy to win the lot in terms of probability.
Okay.
All right. All right. So with that, so with that said, let us look at these two other examples. So to find the probability of drawing a diamond from a deck of cards, then now you have to be familiar with all the different cards in the card pack. Because for a person who probably is familiar with a card pack, because you have people who gamble with cards too, so they become very familiar with cards, or people who play with cards. So in this case, you would have to know how many diamonds in the card pack. And so someone could probably tell me based on their familiarity with the card. So how many diamonds in a card pack, guys?
Sir,
Go ahead, Mr.
sir, 13.
All right, 13. And everybody would understand why we get 13. So if you are not familiar with a card pack, then you would not be able to say that there is 13. But if you are familiar, then you would realize that in terms of the different patterns on the card, we have what we call diamonds, we have what we call spade, we have what we call clubs or beads ring, and we have what we call hearts. And these are the 4 different patterns that occur on card. But for each pattern, you have 13 cards for each pattern. And it is based on numbering of each pattern going from 1 to 13. So every card or every pattern has an ace, a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a jack, a queen, and a king. And that's how we get the 13 cards for each of the different patterns. All right, so each pattern carries 13 cards. All right, so for the diamonds, you would have 13. The total amount of cards would be 52. So the probability of drawing a diamond would be 13 out of 52. All right. For the next one, next question, 20 discs are marked with the number 1 to 20 inclusive. They are placed in a box and 1 disc is drawn from it. What is the probability that the number on the disc will be a multiple of 5? And so if you have 20 discs and you number them from 1 to 20, so the probability of getting a multiple of 5, you would have to think about the multiples of 5 from 1 to 20. And here you would have 4 multiples of 5 from 1 to 20. You would have 5 itself, 10, 15, and 20, because all of these multiples of 5, you know that 5 would be a factor of these multiples. All right, so how many multiples of 5 we have out of the 20? We would have 4. And hence the probability of getting a multiple of 5 would be 4 out of 20. And if we cancel that down, we get 1 out of 5. All right, guys? All right, from last class, we talked about non-equiprobable events. And we were saying that in this case, where you may have tossing of 3 different coins altogether, then each event, you will get a different combination of results. So if you toss 3 coins at once, the possibility that they may all turn over and you have all heads. That's one possibility. You may have them turn over, you have 2 get heads, or the first 2 get head, and then you have a tail. You may have another possibility where, so we're looking at the, and if we're looking at these coins based on coin number 1, coin number 2, and coin number 3, then we know that each of these coins has different probability of turning up a head or tail. So the probability of getting all 3 of them, then you may have the first 2 showing heads and then the other getting a tail. Then you have the first showing a head, the middle one showing a tail, and the other one showing a head. Or you may have the first a head and the other 2 a tail, and so on. But when we look in total, we have 8 possible combinations. Now, from these 8 possible combinations, we can determine probabilities for head. All right, so here we have probability for 0 head, probability for 1 head, probability for 2 head, and probability for 3 heads. Now, if you examine the probability of 0 heads, that means you don't have any head. You would only have 1 chance of that happening where you have all tails. If you look at the probability of getting 1 head, then you look in the combination to see how many of these have 1 head in them. So if you look here, you have 1 head right here in this one. Let me circle the head by itself. So you have, in this combination, you have 1 head. This combination, you have 1 head. And if you look closely, you may have 1 head here. So in total, how many of these combinations have 1 head? You would have 3 of them. So the probability of getting a head would be 3 out of 8. Probability of getting 0 head would be 1 out of 8. Now, if you look in terms of 2 heads, this one here has a probability of getting 2 heads because you have 2 heads occurring. This one has a probability of getting 2 heads too because you have 2 heads occurring here. This one has a probability of 2 heads. How many of these have probability of 2 heads? Then you actually have 3 over 8. And the probability of getting 3 head is just 1 chance of that happening. So we would have the probability of getting 3 head would be 1 out of 8. Now, when you compare all these 4 different probabilities, if you look at them closely, they would not have the same chance of happening, right? And so because they don't have the same equal chance of happening, then we say that they are non-equiprobable events. Now, for equiprobable events, you must have the same chance of happening. So in the case of throwing 1 dice, you have the same chance of getting all the faces on that dice. So you can get an ace, a 2, a 3, or a 4 in 1 shot, but you can't get more than 1 of these at a time. So for those, for 1 die, you would have equiprobable events. But for 3 coins, you'll realize that you may have different probability for 0 head, 1 head, 2 head, and 3 heads. And so these are referred to as non-equiprobability events. All right, guys. All right, so with that said, moving on to our next slide, we say that in probability, we can use set notation. All right. Now, notation is just a big word for symbols. So set symbols. If you go back to what we were doing in sets, you know that we talk about universal sets. You know that we talk about set A, B, C, or D. And we say that these, the universal set we represent with a rectangle on the Venn diagram. And then now we have sets that we may represent with circles in the Venn diagram, but you have sets also outside of that circle and so on. So we will consider that within the Venn diagram, you have various subsets, right? So in probability, what we can do is think of the total possible outcome as everything in the Venn diagram. Now we can look at what we are favored out of the total. In this case, we put what we are favored in circle here. So A is what we are favored. And so the probability of A, and based on the definition of what A is, based on the set builder's notation here, it says, suppose the universal set is X such that the value of X is greater than 2, but less than 10. All right. So you want numbers that would be between 2 and 10. Are you with me, guys? So we have numbers between 2 and 12. So from those numbers between 2 and 12, we would have 3, 4, 5, 6, 7, 8, 9, 10, 11. And of all of these numbers between 2 and 12, we want to find the probability that the numbers are odd. So from this set, we could choose all the numbers that are odd. So we know that in terms of an odd number, 3 would be an odd number, 5 would be an odd number, 7 would be an odd number, 9 would be an odd number, and 11 would be an odd number. So all of those odd numbers, if we're using Venn diagram to represent them, we could put those in a circle. And in that circle, those are the ones would be what we are in favor of. So if we are writing the probability in terms of set notation, so the probability of odd number, remember this symbol here in set, n bracket A means the number of members in A, and n bracket U would be the number of members in the universal set. So how many members in A? You simply go and count them. So if you count, you see that you get 5 members in the circle. And the number of members in U is the entire number of elements in the universal set. So you would count what is outside the bracket, outside the circle A, as well as what is inside the circle A, and you will get a total of 9 members. So out of that total of 9 members, you have 5 of them which are odd.